Probability notes continued. First, let's go over some definitions. Remember that the definition of likelihood is how possible it is for something to happen. That would be impossible, certain, equally likely as unlikely, or just unlikely, or just likely. For probability, remember that that's a number between 0 and 1 that represents the likelihood an event will occur or happen. Don't forget that 0 is all the way on the left and 1 is all the way on the right, with 0.5 or the fraction 1/2 being right in the middle. Remember that these numbers are probability, and then the words impossible, unlikely, equally likely as unlikely, likely, and certain are the likelihood. In the last video, we went over theoretical probability. That's when you're trying to find the probability of an event, and that is when you have the number of favorable outcomes over the total number of possible outcomes. Don't forget that this is what you think will happen. You're just looking at numbers and the possibilities. Now here's the new definition, experimental probability. Experimental probability is when the probability of an event is the number of favorable outcomes, or things that actually can happen, over the total number of trials. You will notice that this bottom is what has changed from theoretical probability, because this is what actually does happen. This is when you do an experiment and try and see what actually happens. It's not just based on numbers on paper. Let's look at some examples. Your directions are to write the experimental probability as a fraction and convert it to a decimal. Todd spun the spinner at right 8 times and recorded his results in the frequency table. So let's actually do the experiment and spin the spinner. Your first one is blue. The next one is blue, so we'll put a tally mark in blue. The third one is white. We'll put a tally mark in white. We have another blue, so we'll put a tally mark in blue. We have gold, so we'll put a tally mark in gold. Another gold. We finally have a red. And our last spin is gold. That means that we had 1 red, 3 blue, 1 white, and 3 gold. The first question is, what is the probability of red? So remember, we're going to start with a fraction, and at the bottom we put how many possible times did we do this, and we did it 8. Then we need to put whatever our frequency was for red, which is 1. So the probability of red is 1/8. When you convert it to a decimal, it is 0.125. Now let's look at the probability of blue or white. Again, with the fraction, you're writing how many total times did we do our experiment. That was 8, that's at the bottom. When you look at blue, we have 3, and white we have 1. So it would be 4/8, and we can reduce this to 1/2 because you can divide 4 by 4 and 8 by 4. Then when you convert it to a decimal, it's 0.5. Finally, look at the probability of not gold. So again, we have our fraction. We tried it 8 times, so that goes on the bottom. And now that we're looking at not gold, we want everything besides it. So we have 1 red, 3 blue, and 1 white, which is 5. So the probability of not gold is 5/8, and we convert that to a decimal, and it is 0.625. In the next example, the directions are use the theoretical probability to make a prediction about the number of times it would occur in each experiment. Student council surveyed 60 students about how many pets they have at home, and 16 students said they didn't have any pets. Based on the data, predict how many of the 300 students at the school wouldn't have a pet. So we will look at the probability of no pet. So no pet will go in the parentheses. We already know that the total number of students they surveyed was 60, so that will go on the bottom. And then on the top, we want how many did not have pets, and that was 16. And you can reduce that fraction by dividing by 4 on each side, the top and the bottom, and you will get 4/15. Now we need to find out how many would that be out of 300 students. So all you need to do is multiply 4/15 times 300. And when you do that in your calculator, you get that 80 students would not have a pet. Again, you're going to use the theoretical probability to make a prediction about the number of times it would occur in each experiment. Al flips a coin 500 times. Predict how many times he would expect it to land on heads. So we want to know the probability of heads. And if you remember, we need to find the fraction of this probability. There are 2 possible choices, so that would go on the bottom, either heads or tails, and heads is just one of them. So the probability of heads is 1/2. Now you just multiply 1/2 times our total number of times, which is 500, and you will get that it should, in all theoretical probability, land 250 times on heads. Again, use the theoretical probability to make a prediction about the number of times it would occur in this experiment. Robin got 8 hits in 25 at-bats so far this season. Predict how many hits you would expect him to get in 600 at-bats. So first, we're going to look at the probability of hits. When you look at what we had so far in the data, we had 25 total at-bats, or times that Robin was at bat. Then, out of those 25 times, Robin had 8 hits. Now, we want to look at 600 at-bats. So we would multiply 8/25 times 600 to get how many of those 600 times would there, or should there be, a hit. So 8/25 times 600 is 192 hits that Robin should get. And now we have Greg rolls a standard number cube 10 times. How many times would you expect him to get a number greater than 8? So we want to know the probability of a number greater than 8. When you think about a number cube, there are 6 sides to a number cube, so that goes on the bottom. Then it's asking, what is the probability of getting a number greater than 8? Well, on a number cube, you should have a 1, a 2, a 3, a 4, a 5, and a 6. There's no 8 on a number cube usually, or even numbers that are greater than 8. So there's a 0 chance of getting a number greater than 8. So you can reduce that to 0. Then when we look at out of 10 times he does this, what is his probability? So we do 0 times 10, And again, you get 0 times. There are 0 times that he will ever get something that is greater than 8 on a number cube when he rolls it.